Okay, so today's lesson is over the converse of the Pythagorean theorem, which basically just says if you're given three sides to a triangle and you can put them into the Pythagorean theorem and it works, then you have a right triangle. So if I were to put these numbers into the Pythagorean theorem, making sure that the 5 is the longest side, so it has to go where C is. 3 squared plus 4 squared equals 5 squared. That would be 9 plus 16 does indeed equal 25. So yes, it is a right triangle. You can also do the same thing on your calculators if you have them. If you put in, this isn't Mini 3-1, you don't need that. You just type it in exactly as you have it here. 3 squared plus 4 squared equals 5 squared. Hit enter and it'll tell you that it is true. So yes, it is a right triangle. So let's skip down to problems 1 through 4. It says which of the three sides would have to be the hypotenuse. Remember, the hypotenuse is the longest side. So when they give you three numbers, for example here, 5 would have to be the hypotenuse. It would have to be the C in the equation. Here, 13. Here, I'm going to check and see what the square root of 2 is. 1.4, so that is the longest side. And here, square root of 13 is 3.6, so that is the longest side. Now, one thing that I don't like that this worksheet did was they put the longest side, they always put it third. That's not always going to be the case. You have to be careful and make sure that you are actually putting the longest side in for the value of C. So look at numbers 5 through 8. We want to prove that these are right triangles or not. So I'm going to put, this is my C, I'm just going to circle the longest side on all of these, make sure that it goes after the equal sign. 8 squared plus 9 squared would have to equal 10 squared. This is 64 plus 81 would have to equal 100. This is not true. 64 plus 81 does not equal 100. This is false. Now, if you wanted, you could just use your calculator. 8 squared plus 9 squared equals 10 squared. Hit enter, and it will tell you it's false. Okay? 12 squared plus 14 squared equals 15 squared. Let's see. 12 squared plus 14 squared equals 15 squared. Nope, that is false. Okay. 10 squared plus 24 squared equals 26 squared. That one is true. 10 squared plus 24 squared equals 26 squared. True. So these three side lengths would make a right triangle. Okay, here, 14 squared plus 15 squared would have to equal 21 squared. Is that true or false? Let's see, 14 squared plus 15 squared would have to equal 21 squared. Nope. So we only have one right triangle here. This is the right triangle. None of these other side lengths would come together to form a right triangle. Okay? Right here we have a word problem. It says a parking lot has 4 sides. I'm going to draw a picture of what it's describing. And it says one pair of opposite sides is 100, and the other is 60. And then it says the distance from one end of the longer side to the opposite end of the shorter side. They're talking about a diagonal here. And they're saying that's 120. Is the parking lot a rectangle? Remember, if it's a rectangle, you can divide it into two right triangles. So is it a rectangle? We're going to see. It says if the distance given form a right triangle, which number is the hypotenuse? Well, the 120, because it's the longest side. Okay. Which numbers are the two sides, or the legs? That would be the 60 and the 100. So fill in the numbers in the Pythagorean theorem for this problem. So we'd have to put the 60 plus the 60 squared plus the 100 squared would have to equal the 120 squared. So let's simplify. 60 squared is 3,600. 100 squared is 10,000. And it would have to equal 120 squared, which is 14,400. So the question is that true? 3,600 plus 10,000 would be 13,600, and that does not equal 14,400. So this is a no. Are the two sides of the equation equal? So is it a rectangle? No. Because a rectangle can be divided into two right triangles. These are not right triangles. Because the Pythagorean theorem didn't work. Okay? And then this last page is just showing you different ways that the Pythagorean theorem might be modeled. Remember, they like to model the Pythagorean theorem using squares. They put the squares together to form the right triangle. And if you could put these squares together, would they come together to form a right triangle? Well, I'm going to make that my C, and I'm going to do 15 squared plus 36 squared equals 39 squared. Is that true? Let's see. 15 squared plus 36 squared equals 39 squared. That is true. So yes, this is a right triangle. Here, if you'll notice, they've got the numbers already squared and inside the squares, as opposed to here the lengths are outside of the square. These numbers have already been squared, so I don't need to square them when I fill them in. I would just say 196 plus 2,304 would equal 2,500. 196 plus 2,304 equals 2,500. That one is true. So yes, this is a model of the Pythagorean theorem. Remember, I said that you have to show squares to model the Pythagorean theorem. This is a rectangle. This is not a good model of the Pythagorean theorem. It involves squares. Same thing here. These are rectangles. This is not a good model of the Pythagorean theorem. All right? This is a 5, this is a 12, and this is a 13, if you count those squares. So, does 5 squared plus 12 squared equal 13 squared? It's a common Pythagorean triple. I know it does, but I'm just going to prove it. Yes, this is a good model of the Pythagorean theorem. Here, I would say, does 4 squared plus 4 squared equal 25 squared? I don't even really need my calculator for that one. Obviously, 16 plus 16 does not equal, oops, that should be 5 squared, which equals 25. Jump the gun there. I'm really bad with does not equal 25. 16 plus 16 is 32. So this is a no. Okay, moving on. This visibly doesn't look like a right triangle to me, but you can't really go by looks. I'm going to go ahead and double check and make sure. This is an 8, this is a 10, and this is an 11. So if it's a right triangle, 8 squared plus 10 squared would equal 11 squared. So let's see, 8 squared plus 10 squared equals 11 squared. That is a no. Okay. Right, this is a 3, 4, 5. This is a yes. That is the most common Pythagorean triple. And these are all rectangles, so this is not a good model of the Pythagorean theorem. And that is it.